Today we are going to see how to do rest roughing. Rest roughing is nothing but wherever your bigger cutter has not entered into the region, in that particular region itself we need to machine. The software will recognize wherever the material is left behind, there exactly the cutter will go and it will try to remove the material. Otherwise what happens, you cannot directly move from a bigger cutter to the finish cutter, because if you take for a finishing, if there is a load is more, then your cutter will break. So to avoid a breakage of cutter and also to have a proper removal of material, we need to do rest roughing operation. Here I have generated one roughing operation. When you verify this one, you will come to know there are material is left behind, and for which this cutter will not go because this cutter diameter is bigger than the region. So that's why it is not entering into that particular region. To remove this particular area, we have to use smaller cutter in a rest roughing, and we need to show that we are willing to remove the whatever the left out material. So to take rest milling, you should know the minimum distance between the walls. To measure that minimum distance, you have to use this analyze option. In analyze, specifically you have to go for measure. Particularly we are looking for measuring the distance. So in selection filter result, you may observe some other features like angle, face, solid. Those are active mode, so I am turning off those one by clicking here. So whichever is showing orange, it means that is active. So I want to measure distance. So here it is asking vector. So by default you have to go to this object. My first object will be this one, and the second object will be this particular face. So at that moment I came to know the distance between the two specific walls is 19.79 mm. If I take a cutter which is lesser than 18 or below this particular value, then I can move my cutter inside that particular region. I would like to go for 16 cutter. Like that, you have to decide which diameter cutter you have to use for rest roughing. Initially you go for bigger cutter for roughing, and then you followed by rest roughing. To insert a rest roughing operation, click on workpiece, go for create operation. Here you may find the option rest milling. Once you observe, whenever you open rest milling, the utility or the pop-up is same as that of cavity mill. There is a slight changes. You have to take level base this time. I will tell you once we enter into this. First you need to create a cutter. Make sure that the diameter of cutter should be lesser than the roughing cutter. Otherwise there is no meaning of rest roughing. So I am taking a tool with a 16 diameter. Here I will name it as end mill 16 with nose radius 2. I will mention the values. If you want, you can take one holder from the library. Milling drilling. I will take this time as a medium, call it one. Say OK. You have to mention a proper tool length and everything here in a tool. So tool length I will keep it here as 45, and the flute length I will keep it as 40. Length is nothing but the holdout length, whatever the tool length which is you are keeping outside the holder. So number of cutting edges, this time I will take it 3, and tool number I will give it as 2, adjust register as 2, custom register as 2. Same value you have to give. Then the most and foremost important thing is here is we need to keep little bit lesser step over. You might have remembered while doing roughing we kept 60 to 70% or 65 to 75% you need to keep, but while doing rest roughing you have to keep 30 or 20 to 30 you need to keep. Here I will take cut pattern as follow periphery. If you want you can take, otherwise keep follow part. This time depth per cut I will take 0.35. This depth per cut depends on the type of cutter which you have used and the type of material which you are cutting. For aluminum or something you can directly to take 1 mm. For cast iron or something steel you have to take 0.35 for a 16 cutter or 0.3 depth per cut. If it is a titanium then you have to take 0.1 or 0.05 depending on the grade of the material. In cutting, always remember while doing rest roughing, don't take this level first. If you take level first, then unusual movements will be more, because you might have observed there are 4-5 regions where cutter has not entered. To machine that one, if at all, if it is moving from one region to another region to maintain its level, then there will be lot of non-cutting moves. Instead, you have to take depth first, as we have explained these two terms in our previous session. So in containment, so if you want you can make a note. In containment, instead of use 3D you have to keep use level based. Someone may ask what is the difference between use 3D and use level based. If you keep use 3D, then you have to generate roughing and rest roughing at a time. At a time means both you should generate at a time. If you change anything in the cavity mill or first roughing operation, at that moment it will get affected. If you keep level based also it will get affected, but if you keep level based means individually you can generate the operation. So I will keep use level based. You may observe here, depending on the levels it is taking the passes. It is depending on the use 3D. The accurate will be use 3D, and also very easy to understand the levels is use level based. You keep this use level based. After that, directly go to this feed and speed, and I will give spindle speed for 16 is 6000 rpm, and I will mention feed as 1200, and I will say calculate. You have to calculate every time. So in more you may see while engaging I will keep it as 80% of whatever feed which I have given. So always try to maintain the engage percentage like 80% or 75%, so that while initially while engaging to the workpiece, that has to be lesser value. If it's having a greater value, then there might be sudden load on the spindle. So because of that your inserts sharpness get lost, otherwise your cutter will lose its sharp cutting edge. To avoid that one, always try to keep engage percentage little bit lesser than 100%. So in cut levels, so it is taking top to the bottom. Yeah, it is okay, it is required for us. And also you may observe there are some holes which I have already patched by using patch opening option in CAM itself. In strategy, here I will keep my strategy default. If I keep, then whenever I mention trim boundary, then my cutter while taking non-cutting move, it will go in the non-cutting region. So to restrict that one to NCM trimmed means whatever the boundary you have mentioned, in within that only it will try to machine. So it is better to keep follow boundary, so your cutter will be always try to be tangential to that one. So now we have not given any trim boundary. If you want you can go to this geometry and specify this trim boundary. This time I will take this particular face, bottom face, to specify the extreme edges. The side trimmed is inside means inside region will be ignored and outside it will get machined. I don't want like that. I want to machine within the boundary. For that we need to change the side trim to inside to outside. If you do like that, then outside region will be ignored, only within the boundary it will get generated. Say okay. And we are here in a strategy. We kept here follow-up boundary. If you want to do smoothing, right now I kept none. If it is a rectangular pocket, then it will follow the blue color lines you may observe. Like that, it will follow the path. If you want to change to all passes, then you may see the flow of path will be like this. So the one uh, who is experiencing the jerk movements on a machine, if at all, if you want to avoid those jerk movements, then you have to do this smoothing to all passes. Your machine will run smoothly when you keep all passes. Adjust feed rate, it is for whenever there is a motion from directly circular to the linear or linear to the circular. At that moment, if you want a same feed, then you keep it as it is. Sometimes what happens, there might be a chatter mark whenever there is a circular motion with high feed rate. So if you want to avoid those chatter marks on the part, you need to set this adjust feed rate. Now I kept on all arcs, so I am mentioning here the range 0.5 to 1. It means 50% to 100%. Depending on the curvature, it is deciding. It should not go below the 50%, it should not exceed, or it should not be equal to 100%. If you want to slow down before entering to the curvature radius, that time if you keep current tool, then it will go down by 10%. Means if your cutter is 100 mm, then whenever curvature is starting before 10 mm only, it will get slowed down. Mostly practically, maximum people will not keep this until they face any issue. So go for none, it's better. So open passes, if in image you may observe when it is going to the starting point to the end point, again it is lifting and it is going for the next consecutive pass. So while doing that one, it is lifting again. Every time it is lifting, you may see there are more non-cutting moves. If you want to avoid this, then you have to use this alternate direction. One engage, one out. Whenever the means adjacent passes will be covered. So it is better to keep this alternate cut direction. So small closed areas, if you want to ignore, then please ignore. Otherwise, if you want to cut, cut. So now I will keep cut because I know the minimum range, minimum distance between the two consecutive face or the front face is 19 mm, which we saw by using analysis. So now I can cut this particular region. In non-cutting moves, engage, helical I will keep, and I will reduce the helix size. As it is showing 90%, I will take it as 50%. The ramp angle with which it is engaging to the workpiece, 15 degree, I will make it as 8 degree. So again here the ramp length, minimum ramp length, if it is not allowed, then I will give 20%. Means in some space, if it is not able to make that helix, then it can make 20% of diameter of the cutter and it can engage. So retract I will keep as it is. In avoidance, it will take by default. We have defined all these points. In post processor, no need to define these points. So in some special cases, if you are using any T cutter to make groove, at that moment you have to mention the start point and return point, so that your cutter should not collide with the non-cutting parts. So smoothing I will turn on. Always try to get this particular smoothing on. In transfer rapid, as you know, between region means from one region to another region, whenever it is going, I will keep previous plane, as we have discussed this during cavity mill operation. Here I will give that as 2 mm, and here also I will mention previous plane as 2 mm. Means within the region, whenever it is moving, at that moment it will take a 2 mm distance, safer distance, then it will go to the start point. If it is different region also, it will mention it will take 2 mm safe clearance from the peak surface. Otherwise, people may keep this 5, 3, depending on their experience. I will try to generate this particular operation. You may see the progression, how it is generating. This computing speed depends on your computer hardware also. If you have good graphics card, good with i7 processor, and RAM is also good, that time it will generate lightning speed. I may verify this one. Go for this analysis. Here we have not given the stock. Please try to give stock, because if you give 0 here, what it will do, it will try to finish it. So don't mix roughing and finishing at a moment. So always try to keep part side stock. Means 0.35 material will be left behind for finishing. Otherwise, you try to maintain the practice. Whenever you do verify, at that moment go for analyze and look at the points wherever some material is left behind. You may observe software is a very intelligent, and it is knows where exactly the material is left behind. There only it is going. It will not go in another region where if the material is not available. In middle also it will not run. Wherever there is a material, there exactly it will go, and it will try to machine. Please observe carefully. We have kept depth first option, that's why it is removing material in one region up to the depth, then again it is going for the next region. If you keep level first, then here it will remove 1 mm or 0.5 mm, again it will go to the other region, again it will go to the other region. So you should avoid the non-cutting moves. As I said earlier, whenever you do this rest roughing operation, you go for analyze again and select the region and see how much material is left behind. Again, if you want to go for rest roughing with smaller cutter compared to this one, then you may go up to the minimum radius which you are willing to acquire. So it is better to have 2 or 3 rest roughing. So directly if you are using, for example, 50 mm cutter as roughing, then again directly you should not go for 16. You have to reduce in terms of steps. Like directly you cannot jump from first step to the directly 10th step. You cannot jump. So we have to go step by step. Means if you are using 50 mm diameter cutter for roughing, that time you have to use 30, then again go for 20, 16, 10, 8, like that you have to go. Now we have used 16. For next rest roughing, what I will do, I will copy this particular operation itself and I can paste this one. Why? I have to reduce my number of selection. Already we have given stock, already we have mentioned the boundary, already we have mentioned the cutting moves, non-cutting moves, everything is defined in this. To reduce programming time, I will copy that particular existing operation rest milling and I will paste. So the main first work is to change the cutter. So while changing, you should not change from here, edit display. If you change this one, then again this earlier operation will get affected. Always keep in mind you have to create a new one. This time I will take ball mill with 8 diameter. Here I will use a holder from a library, Otherwise I will use only cutter. Tool number, everything I will give. According to this cutter, I will give here my step over is 15%, or I will mention in scallop, I will make it as 0.03 micron. Here ultimately whenever your cutter changes, then feed and speed should get changed. So here I will give it RPM is 8000 and feed rate as 800 depending on the cutter diameter. Cut levels also I will decrease 0.35 depth per cut to 0.25. Then again I have to generate. Other things are already defined in previous rest milling. The same operation which I have copied and pasted here. So that's why I am not giving those typical smoothing, avoidance, retract, engage, transfer rapid. Already I have specified. If you are repeating the same operation every time, then no need to go for new. You can use copy and paste option very easily. Now you may observe in the corner there are some material is left behind, so that's why it is going over there and it is trying to machine. Like that you have to use. Now if you see the complete model, there are no regions where this 8 cutter has not entered. Almost all region it has covered. The main region is this one and this one, and also in some regions where corner programming has done. Verify, replay. You can see it is doing a corner programming. So wherever there is a excess material, it will try to remove that one. So directly when you go to the stepping, finishing, then there should not be a load on the cutter. Like this you have to do rest roughing operation. Analyze, see the region. Yes, it is okay. Some region 0.4 it is there, some region 0.35, here also 0.45, 0.35, 0.36, it's okay for finishing. Like this you have to use rest roughing. Thank you.